Thanks for joining, everybody. This is our final episode of this season, and we're going to take a look at software supply chain risks, and analyzing these software packages. And we're going to focus on these two meeting software. We may throw in a third one at the end, depending on time, but we're going to walk through how to do this assessment. We're going to look at what's inside these packages, and then we're going to see what the risks are. We'll see what software looks like under the covers, which is what we've been doing all season. We're going to tie together a couple of different concepts we talked about in previous episodes, but we're going to show you how to do how easy it is to do a quick and rapid assessment of these software elements. This is a little bit about ReversingLabs, and this is what we do. We've been in the malware analysis and threat hunting side. We have a really strong static analysis engine that runs all these things, that unpacks all these different components down to their atomic levels, and then we scan those components. Makes it really, really fast, gives it a lot of depth and a lot of visibility, and then we add our intel into that and do all our extra tagging on the back end, so you see all that and you benefit from all that intelligence, all the work we do, and all our research teams and threat intel teams. So we were applying that to software supply chain, as you'll see in these as we go through this demo. Right. We're going to use our software supply chain security, SSCS, to do this analysis, but we're mostly going to focus on the software and the findings. These are the packages we're going to look at. We knew we were to do BlueJeans and GoToMeeting, but I threw TeamViewer in because I wasn't aware they had a meeting software, and I know them for their remote desktop application. I think that's what they're most known for. I want to take a look at what their meeting software looked like and see if there's any overlap with their remote desktop software, if they're building it on the same package. This is what we're going to look at. We're going to look for security issues, primarily file rot. We discussed this, in previous episodes. We did a whole episode on file rot. What that means is just these aging software components, right? Development, is a high pressure environment. Everyone's doing more with less. The push is always to fix bugs, put out new content, new features, new, keep up with the competition, and innovate yourselves and try and separate yourselves from the competition. So the priority is that, not so much security. And we'll see that as we go through these reporting. This is a quick way to take a look at your software itself, but also assess the vendor and what their CI/CD pipeline, their build pipeline for their software looks like. What kind of tools are in place? What kind of things are they catching? And what kind of things are making it through to that final build? Up till this point, you didn't have that visibility, right? So we were trying to do risk assessments with the tools that we had available, like vulnerability scanners and third-party supply chain scoring mechanisms and these things, but it was really the best we could do with a pointy stick and a rubber band. Now we have actual tools, we actually visibility, and from a third-party risk management perspective, and from a purchasing perspective, you now have the ability to look under the covers, see what's behind the scenes, see what these things actually do, look at their behaviors, and then you can make an educated decision of which one you want to buy, or whether you want to renew a contract for a vendor that clearly isn't keeping up with security and updating their software. So we'll show how to do this, and we'll show how to do each one of these really in just a handful of clicks. And I'll show you some of the background investigation pieces as well. So this is what we're talking about in this software purchasing lifecycle. Again, I wanted to just make sure this was in here so you guys had these slides, but you want to be, your risk compliance teams, your purchasing teams, should educate them as to what you're going to buy. So you should be looking at these reports. And the point of this is just to show you how easy it is. And this is a repeatable workflow that you can actually do. You don't need a ton of experience to read these reports. It's all pretty simple. So we're going to go through these just in alphabetical order, just to make life easier for all of us. Here's the platform. So we run this package through and we get this, upper level report. So it's BlueJeans. This is the most recent version. And this is the MSI. This is the full build. So if you wanted your IT teams were going to deploy this on your network, this is the package that they would push out. So we want to make sure we had everything in here, but it's still only 51 megs. It's fairly small, but it has a lot of components in it for a 51 meg file. We have this maturity level scoring here to give you sort of a sense of where the issues lie and how bad they are. Level 1, these are the most critical things: malware, tampering, that kind of stuff. So if you see anything in this one, that's a full stop. Don't deploy this update. Don't buy this package. Don't do anything. And then the rest, you have to score that based on your risk appetite and the things that you're concerned about, right? So actively exploited CVE is definitely something you want to take note of. So we look at the bill of materials, then we can get a sense of where the issues lie and in whose code these issues are a part of. So we can see publishers here. We look at this list of publishers, and as you would expect, BlueJeans has most of these elements, right? So we can look through all their stuff. But if you look at this just ranked by the number of issues and the severity of issues, BlueJeans, BlueJeans, Verizon owns BlueJeans. So there's some Verizon code in there, right? Some third-party stuff. Microsoft, there's always Microsoft third-party stuff in any Windows application. But to see issues and CVEs in vendor code, that is not a good sign. And this is just quickly, I can tell, hey, there are some problems with this, right? Usually when we see this, CVEs, and it's a lot of these issues are based on file rot and those aging components and those third-party components. But to see this stuff in the vendor code, that's a red flag, right? That this tells you that they might not be running supply chain security tooling, right, in their build pipeline. They might not be seeing these things. They may not really even know what's in their package. After you build it, if it doesn't break, it generally doesn't get fixed. So that's why these things age out over time. As long as it keeps working, no one's ever going to go back and look at it. So we see this, and the companies that have been in the have products out there for a long time, you see this. It's even worse with some of those. So one of the things we can look at again to notice file rot is we'll look at the code signing certificates that are used inside this package, and we'll see how old they are. Right. So again, there's a lot of old Microsoft code. We see this all the time. But look, 15 years ago, this certificate expired. That means the code elements that are in here that were signed by the certificate are even older than that. So given the average lifespan, let's say it's 18 months, right? That may be another year older than this. It was built to the best practices of the time. But, as things evolve and security evolves in this space so quickly that anything over 10 years old, that code might as well be written on a clay tablet. That's how bad these things are. And that's why you see these missing mitigations. You see these extra CVs just pile up over time because these things never get addressed. They never get updated. And there may be an update to this. What is this? Yeah, DEP. That's a mitigation that's been around since XP or Vista, and it's not in this code, right? And there's a bunch of elements that are signed with this, right? So there's, 7 different packages here that all have the same issue, right? You don't have to go that deep. You just know, look, there's old files, and here's the number, right? 8 years old. There's 23 of those files, right? So you can see how this stuff sort of stacks up, right? But we don't see a lot of their own code in here. So that's okay. It's a little bit better, but still, they should see this, right? If they know what's in their software, they should be assessing this, even on a regular basis. Even if it's only once a year they do an audit or something, you can update these things. But if they age out this much, then you can tell that they're not even looking. So we had the bill of materials here. We saw that. We saw some expired stuff. And now let's look at the behaviors real quick. And there's one of them primarily I do every time I look at a package. I want to see the anything that has to deal with enumeration. So I just do a quick search here to find all the behaviors across all these different categories we have, right? And this is the power of static analysis, is we can actually tell you what behaviors that code is able to perform. Where dynamic analysis will just record what actually happens. It's like a DVR. But software isn't like malware. If you don't interact with that software, it generally will just sit there. You open up Microsoft Word in a sandbox, it's just going to sit there until you create a file, download a new icon pack or templates or whatever. It just sits there. It does nothing. Well, I mean, Microsoft chatting in the background, but still. So we want to see what the behaviors are. And I want to see what this software needs from my system, from my hosts, or collects about my network of my users. So I always do this check. 13 is, in line, but we want to see, does this align with our expectations for video conferencing software? So it detects running processes. Okay, I expect that, right? Because when you start it up, it wants to check and see if it's already running. That's fine. Installed devices. Sure, it's video conferencing software. It needs a check for a microphone, that stuff. Again, system drivers, that, groups, I wonder about that one. Adapters just has to do with network stuff, system information. So nothing here looks out of place. It all seems to align with what you would expect for this kind of application. So again, you can dig through a bunch of these other behaviors and look at other stuff that's in here, but we wanted to just do a quick assessment. So we looked at what's in the package, what kind of vendors, right? So you see a lot of BlueJeans, but you see some other stuff, third-party stuff, Facebook, Google, But when you see names in here and you see email addresses show up in here sometimes, then you know that's all third-party packages. That's open source stuff, right? So this is a project on GitHub somewhere that they've added to their package, and they're leveraging that. But again, like the Microsoft stuff we saw, if they're not checking that stuff, then again, this is just more attack surfaces. There are more things that are aging out over time, and they're just going to continue to collect more and more issues. This means this is a growing risk in your network if you choose to have this software. You're currently running this software. This is the kind of thing you want to check for. So we looked at all those things. Now, well, let's look at the vulnerabilities, because this is another way to look at the file rot piece. Is let's see where these vulnerabilities lie. So we'll look here, and all the vulnerabilities. OpenSSL, that's an open source. libcurl, libjpeg turbo, right? So image rendering component, that's open source. zlib, open source. All these things are open source. And look at all the vulnerabilities they have. So a way we can figure this out is to say, is that just buggy software that they shouldn't be using? Or is this an old version that's just picked these things up over time? So a quick way to look at that, and I found the easiest way to do this is just go to your search engine of choice, type in the package name and the release name, and then release notes. That generally gets you to where you want to be. And then from that point, you can find the release history. So that's worked for me. And I just bookmark these things over time as I see, but you can see all these releases here. So the current version is 3.2, but what we're looking at right in this report is OpenSSL 1.1.1. So we can see here that that's 2 major releases behind. So they're updating this, but it's not maintained, right? So here's your old releases, 1.1.1, and what was the letter for that one? I. All right, so let's look for 1.1.1 I, December 2020. But again, this isn't being maintained, so they're doing, bug fixes and they're addressing vulnerabilities, but it's not getting a lot of attention. It's just doing the bare minimum, and this isn't going to last forever. They won't maintain this forever. So at some point, it's end of life now, but it'll just be out of maintenance at some point. When they go to the next version, 4.0, then they're going to probably cut these things loose. But if these vendors don't realize this is in here, they won't even notice when that happens, when it stops being maintained and there aren't any fixes coming to it anymore. Right? This is important. This gives you a way to assess that vendor itself and all the other software coming out of there as well, because these tools, the security tooling and GitHub and all the things they use to build their code are enterprise-wide. So if they have 10 different products they put out, all those teams are generally going to use the same software. So they're going to have the same blind spots. So you'll see these same things flow through, and that gives you a way to assess that vendor and whether or not you want to work with them anymore. Same thing with some of these other ones. zlib we saw in there, right? So we'll look at zlib, and it's 1.2.11. So let's look at that, 1.2.11. So the recent version is 1.3. But again, zlib it's an open source thing, but they're only maintaining it. They only update it really when there are new vulnerabilities found or new issues. So they're patching issues, but they're not adding to this software over time. So you really can't read into the release numbers, right? So 1.3 is the most current version. Well, you're only a couple of versions behind at 11, but actually that one was published in 2017, right? So look how the age of this code, it just sits there. And you'll see zlib is one of those ones that everyone uses and no one ever updates. So every package you look at is good to have zlib or OpenSSL in it, depending on what it does. If there's network communication involved, it's going to use OpenSSL or OpenVPN. And those are the same things. You'll see these same things over and over and over, which is what makes this repeatable. Same thing with curl, right? Curl is maintained, but they're constantly releasing this stuff. And you're looking at 7.0 in here. That's a whole major release behind. So you're still going to have more and more security issues. And over time, this is where you may get hit with the next Log4j. And when it shows up in something old like this, no one knows it's even there. And then it's just mad scramble to find it and patch it. And, again, you're placing a lot of faith in that vendor to fix these things. So we see a lot of issues with this. There's a lot of file rot in BlueJeans. So let's see how it compares to the other ones. So let's look at this one. This is GoToMeeting again. Small file, 20 megs. I like that, right? I like software that's focused. I don't need a million different features in this stuff because that's more attack surface. So especially for features like this, where they're secure, like VPNs, we did last week, we talked about VPNs or meeting software. I wanted to do that one thing, secure that one line of communication and nothing else. The more stuff that's in here, the more vulnerable it is. The more CVEs you have, the more ways this can be attacked and leveraged. So small file, not a ton of components. So this is a plus for me. This is what I look for. I like this. There's a low level issue here, right? There's a private key leak. You see private keys in these one. This is the front end to a back end service. You'll see that. So it's not as critical. That's something I'd look into, but you expect to see that stuff here. So if we look at the bill of materials and we just get a quick view of who's put this, see log me in, right? That was the company. I think it's called GoTo now. Unknown publishers, there's only one, and it's their own GoToMeeting, right? So there's not a lot of third-party stuff in here. Now let's look at signatures, right? There's only one code signing certificate, and it's still valid. Great. That means they're constantly updating, because log me in, GoToMeeting has been around for a long time. They're one of the original players in this space. So this means that they are taking this stuff seriously, and they are updating at least their own code and their own stuff. So let's look at the vulnerabilities, right? They have a lot of vulnerabilities. Let's see where they lie. And we'll just look real quick. Hey, look, that looks familiar. So 1.2, right? The last one we saw was 1.1.11. So again, this is newer, but still OpenSSL 1.1.1. The letter tells you when that patch was updated, but this is still 2 major releases behind. So they put this in, it worked, and then they never touched it again. Same thing with libcurl. Right, that version of libcurl for GoToMeeting is 4.5 years old. Right, so they put it in and then didn't touch it again. Right, this is something you want to know about your vendors. And this is a small package too. So and now let's look at the behaviors and let's see their enumeration. Only 7. Right, and this is how you want to do this. And this is especially important to do this cross comparison with similar elements, similar packages do the same thing, because you need that context. You need to know what's normal across all of them, and then you can pick out those anomalies. So this is, again, small package, narrow focus, doesn't do a lot of extra stuff. That's great. I definitely want to see that. All right. Did have some file route issues, but compared to the previous one, it's not so bad, and the enumeration isn't bad, so it's not collecting a ton of information. So just a couple of clicks, looking at a couple of things, I scored this one better than BlueJeans. Let's look at the third one now. And this is TeamViewer. Again, small size, 60. It has a lot fewer components, right? The first one was 55 megs, and it had a couple hundred components. So, structure matters. It tells you how many different things are in here and how many of those things are likely to be third-party applications or open source. So we look at the bill of materials again, and we can see here there's the issues are ranked. And we see this Afrosoft. We'll come back to that in a bit, but we see TeamViewer. So again, their own code has some vulnerabilities, likely independencies, and we'll see that in a second, right? But again, this is their code. They should know what's in their code. And the fact that they have these issues and they're not getting fixed, that's not a great sign. And there's a lot of their code that has issues. So this is worse than the previous 2 we looked at. Right. And now you have that context from quickly going through the other 2. Now I have a frame of reference for this third one. And then you can sort of get that scoring done. And this really, if you're doing nothing right now, this is way better than anything you're doing now as far as risk assessment goes. It's actually powered by data and the visibility into that platform or into that package. So a lot of different publishers. So a couple of open source, but this Afrosoft is in here a lot. So we'll take a look at that in a second. Let's go to the behaviors. Again, I want to see how this behaves. So we're the enumerate search. And here, this is what I was afraid of. Now there's 20 different, so it enumerates 20 different things, whether it be your system, the users and stuff. So some of that's important for video conferencing software, but a lot of it in here isn't, right? Installed devices, we talked about that. We want to know. Adapters, sure, that's fine. These 2 I question heavily. Why does your meeting software need to check for remote desktop sessions? The other 2 didn't, and they still function. They've been around for a long time. But TeamViewer is based on, they have their remote desktop software. So maybe this package is built on that software and has these capabilities. That's more attack surface. I don't like that they're collecting this information, right? Your BIOS information. The other ones didn't need that. Firmware. The other ones didn't need that, right? So these are the kind of things you can compare that to. If you looked at this blindly and this is the first package you ever saw, you wouldn't really know which things stood out. But now we have a frame of reference and we got that in, what, 5, 10 minutes maybe? So all these things, enumerate peripherals. Again, sure, it needs to find the microphone. It needs to know what browser it is. Some of this I'll take, but these two I really don't like, right? So I would score this lower than the other two just based on that because I don't like it collecting that information. What is it doing with that information? So we look at the bill of materials. So let's look at the vulnerabilities in this one. And there's two, right? zlib. All right, good deal. Not too bad. 1.2 version, so they're newer. And there's only a couple of vulnerabilities. So this is okay. And you do see this a lot where you'll see multiple versions of the same open source package or third-party component in there. They're dependencies of different software. Every time they create a new, you know, a new feature and then they put new code in here, they build that. And if they need a third-party component, they should be hopefully pulling in the most recent version. And that's how you see 2, 3, 4 of these different versions in a software package. Again, tells you something about the vendor. When they put a new version in, you'd think they would go back and look at all existing versions and update those as well. But that rarely happens, right? And this isn't really that bad, but all software looks like this. You can't explicitly trust any software because it's all built this way, all of it, right? It's rare to see a really good package. I'll tell you the best packages right now that I've seen recently are 3CX because they got hit. But when I run their packages, I can see that they didn't just take that malware out. They didn't just fix the issue. They doubled down on security, and every new release has fewer issues and fewer issues and fewer issues because they're taking it seriously. And that's what I want to see from a vendor. I don't care if you got hit and you fell over. I want to see you get back up and do better. And 3CX has definitely done that. So don't, discredit anybody who happened to have an attack because, it's how they recover from that attack that tells you something about them, right? If my vendor gets hit and all they do is take the malware out and it's business as usual, I need to find a new vendor. So we looked at a lot of, different elements here, but by now we should have a pretty good sense of where it is. Now you'll have to score these on your own just based on the information we looked at, but it's more information than you've ever had looking at these different components. So hopefully this helps you, see how easy it is to do this assessment, how rapid it is, and that you don't need a ton of time and experience. You don't need a whole team of incident response folks or reverse engineers to do this kind of thing, right? It's available to you now. So let's go back to the deck. And it looks like we got a couple of questions here. So let me, what happens when a vendor program manager informs me, the client, that the update to these versions will break the functionality? That's a legitimate ask, right? That is a legitimate question. And that's sort of where I stand when I do these assessments. So when I see this stuff, these aging components in here, especially when it's major versions behind, then that is a factor, right? Is how much effort will it take to upgrade that? But when you're doing a software assessment and you're deciding what software you want to put on your network or purchase, is that really something you want to accept? If they're not willing to put in the work, so either when you see this flow through the package, I look at it, it's either two things. Either they don't know that these things are aging out and they just don't have the visibility or they're not running the tooling, or they know it is, but they realize it's too much effort and they're just going to let it ride and hope for the best. So they're passing on that tech debt to you as the consumer. And it's just a ticking time bomb. When is it going to blow up in your face? It may never, but it's risk. There's never a smoking gun generally, unless there's malware. There's never one thing that you say, oh, I'm not touching the software. Risk assessment is sort of a painting. Each of these little components are a brushstroke. It paints the picture of what the risk profile for this piece of software is. When you push something like this out, it's not a one-time thing. It's not SQL Server, right, where you have a main server and you may have 2 or 3 running. But this stuff goes on to all your desktops, all the people that are using this, the remote desktop software. So you just multiplied your attack surface by multiple times. Is that acceptable to you or not? I don't know. But that is going to be the excuse you get from vendors a lot of times. Well, we'll have to redo a bunch of code. Well, then you're not serious about producing secure code. You're not serious about defending your customers. And to me, that these days with the supply chain attacks being the way they are, that's the wrong answer. Yep, especially in the federal government. Exactly. Right. Um, they're always going to be behind. Right. And the problem with that too is the government doesn't build anything. Right. They contract everything out. So you're contracting somebody to build you a piece of software, a custom piece of software to do whatever, but you have no way to check that. Like, how do you assess that? How do you know it can do the things, right? You run it and yeah, it looks fine. And maybe you run a vulnerability scan against it while it's running to see what the attack surface looks like. But if you can't see it to this level, you really don't know what you're getting. And that's all it takes. If you have visibility into that software and you're paying someone to deliver that to you, you have the visibility with this tool to go back to them and say, no, no, look, you have these couple of things in here. You're using these aging components. Fix that, or we're not going to sign off on this. If you don't catch that before you take delivery of this thing, then you're stuck. Right. And we know the government and the military, right? Every government agency and all military bases everywhere have a handful of NT4 boxes running because there's a custom piece of software that's really critical to them. And that company is out of business and no one knows how it works. So it just sits there and no one touches it. That's just life. But the point of this risk assessment and digging into this stuff is to reduce that attack surface, to reduce the risk that you have. And this is what it takes. You do have to do it step by step by step. Really good questions. Thank you. I think we're just about time here. So any other questions you guys have, feel free to contact us, right? If you want to take a look at SSCS, there's a free 2-week trial. Upload packages, take a look at this stuff. All you have to do is sign up. The link's right there. You'll see this in the deck that you get. Questions and comments, right? You can contact us with questions about this stuff. If you're thinking about software supply chain or any of this stuff, shoot us a question. We'll answer you. And this is how you contact us, right? So again, we'll have that questionnaire, the poll going on. I'd love for you guys to fill it out. Give me some feedback. Otherwise, have a great day and everyone have a good holiday season. Thank you all for attending.